Okay guys, this is going to be a kind of quick video, I hope, just about the forms of quadratic functions. And I know this may seem a little confusing at first, and that's okay. This is something we're going to talk about for a while, so hopefully the more we talk about it, the less confusing it will be, okay? But basically, how we talked about quadratic functions, right? So something where there's like an x squared term, right? An f of x equals x squared or something like that. We have three different forms that we're going to be writing those in. And what's important to understand is that they all are expressing the same thing. Okay, so they all say the same thing, right? They just look different and they give us different information, but they're all represent the same thing. Represent the same thing. So the graph for all of them is the same relationship. Relations is probably a better word than think, right? But so the graph is going to be the same. So our graph could look like this, and we could have three different forms that we write this in, but every form is going to give us the same this same graph. Okay, and so what I'm going to do is I'm just going to show you the form for each of these, and then that's pretty much it, and we'll just kind of this will be it. This is kind of our intro to the fact that there are different forms and they tell us the same thing. Okay, so the first form is standard form. And it's f of x equals a x squared plus bx plus c. Okay, a, b, and c are constants. Okay, so that means they're going to be some number. Okay, and they're going to stay that number the whole time. So an example of a standard form would be, something like x squared plus 2x plus 4. Okay, that would be an example. F of x equals of standard form. Now, what this tells us, and we'll go into more detail later, okay? But just kind of know that it's out there for right now. It tells us that, I'm sorry guys. Get back to this page. It tells us that if a is positive, it's going to open up. Okay, so if a is positive, then it's going to open up like that. Okay, if a is negative, it's going to open down. And I'm just drawing sketches. They aren't going to look exactly like that. But if it's positive, it's opening up. If it's negative, it's opening down. Okay, that's one thing it tells us. That's A. Then the next thing it tells us is C is actually equal to the y-intercept. Okay, C. And we talked about how that was important in the last video. So y-intercept. So this equation, I don't know exactly what it looks like, to be honest, but it's going to look something, I don't know, maybe like that. But what I do know is that the y-intercept is equal to 4. Right there is going to be 4. Okay, just from the fact that C is 4. So that's what standard form tells us, whether or not it's going to open up or down, and then what the y-intercept is. Now, factored form, you guys actually know how to factor. That's what we've been working on. So once an equation is factored, we know it looks like something like x and x there, and then there's not exact variables for this, so maybe x plus 2, x plus 3. Okay, and what that tells us is our roots. Okay, so this is going to open up because this is positive, not negative. If it was negative, it would open down, just like we learned last time. And then these two roots are going to be -2 and -3, okay? And so it's just these numbers, but the sign changes. And we'll talk more about this in a later video. But just know that from factored form, we can identify the roots, also called x-intercepts, right? Also called solutions. Just be aware of all those names. And that's what we can identify from factored form, okay? And then lastly, vertex form. You guys remember what vertex is? It's where the direction changes. And so take a wild guess, right? What do you think vertex form is going to tell us? It's going to tell us the vertex, okay? And it looks like this. A x minus h squared plus k, okay? Where a, h, and k are constants. And it turns out that this a is going to be exactly the same as the a that was over here, okay? So the a is the same. And this tells us, well, first of all, what does it tell us? If we know a is going to either open up or down, right? So we know that. And then it tells us the vertex. And we'll talk more about this later, but the vertex is h comma k. Okay, so if I had an equation like this, or a function like this, x minus 2 squared plus 1, my vertex would be 2 comma 1. And you're saying, wait, this is a negative 2. But we have to look back at our standard form. This is a minus here. So h itself is actually only 2. Now, if we plugged in, if this was plus 2, now what would h be? H would be a negative 2 because you had to plug in, if h was negative 2, it would be x minus negative 2, which would turn into plus 2. And that's kind of why the sign change is weird. Well, again, we'll talk more about this stuff later. I just want to get this as a little intro in. So, main thing from this video, standard form tells us whether or not it opens up or down, gives us the y-intercept, okay? Factored form tells us the roots, x-intercept, solutions, all the same thing. Vertex form gives us the vertex, and they all tell us whether or not they open up or down, okay? So this is just a little intro. Know that all these things, we could have 3 different forms to represent the same function, and we'll look at an example of that later. So, thanks.